This is the next to last video for this book for Friedberg and Suspense. I read in this installment section 7.3. I had already read section 7.4. I did a few problems in 7.2, 7.3, but I also went back and did some problems in 7.1. I felt like I had wimped out and I wanted to do a couple more problems. Could have done more, but I'm near the end, and really, if you've seen my completions of other books, by the time you get to this point, it really does feel like a death march. So I'm ready to be done. Even though I have to say, the last chapter on canonical forms, I love it. I mean, definitely, I consider it to be the best for last. It's a shame. It should have been like a third chapter, and then I would have had a lot more energy and felt more like, the early momentum. So this video will go out on May 21st, but today is May 3. I'm still a little ahead, which I like to be. There were a total of 15 problems, of which 9 were proofs. I'm at 659 problems attempted, out of which 422 were proofs. Some problems were more than one proof in the same problem, so there's a little bit of double counting in that 422, but that's just the way the problems work out. In a separate video, I will outline what I want to do in the next couple of months to finish off linear algebra, but these IIT videos will be in that. So yeah, attempted various problems in section 7.1, 2, and 3. All right, so then I'm going to show the book. I think the canonical forms part of this book. I love it. I think it's really, really in depth. Very thoroughly well done, up there with Huffman and Kunz as far as coverage. Although, of course, in the case of Huffman and Kunz, that book uses abstract algebra, so it's a different take. So yeah, the Jordan canonical form, I already mentioned, I think, in the last video. But then what I am going to mention is that I did go back and do a couple of problems. For 7.1. Then the second chapter, which has the dot notation, and then many really good examples. Although I did find, and I'll show it with the problems, for reasons that I don't know. Maybe it's because it's just near book end exhaustion. Maybe I'm going to call it that. I had some trouble with the problems, and I felt that the examples and the problems were a little different, which they usually are. But anyways, very thorough set of examples for Jordan canonical forms, even using transformations that include derivatives, partial derivatives. And then in the case of section 7.3, which is the minimal polynomial, very, very good content. I really enjoy reading it. It's a quicker read. It's a simpler section. And then, of course, I've already started reading the rational canonical form. And just to, give you the punchline, which will be in the last video, the Jordan canonical form is used for when the polynomial splits, the characteristic polynomial, minimal polynomial split. The rational canonical form is for when they don't. And so in the rational canonical form, your polynomials are all these forms, which are not fully fleshed out, lambda minus t. That's really the punchline. And then the canonical form matrix for the rational canonical form is a little different. This section is a very long read, and so I easily will have all of next week to read it and attempt a couple of problems and then be done with this book. All right, so that was the book. Let's go to the content. Okay, so I was finishing reading section 7.2, then I did the true and false. Did okay, only missed one for section 7.2. I love that. Got confused with the way the dot diagrams went, although I did solve, the problems themselves, the polynomials correctly. Screwed this up of rank and nullity, and I'll be going back and doing rank and nullity again in the next couple of months as I finish linear algebra. I did get the canonical forms correct for these. Couldn't seal the deal on this polynomial, but I still left my scratch work, decided to move on, even though the answer was very simple. Then I finally understood what they meant by the basis. It's actually the basis as it comes out, not as units, as e to the t, which is what I had. And then the same issue again in the next problem. So even though I could do the calculations, I could see where I messed up. Still have problems with how to break the cycles. That's just something that I didn't really see. I didn't break the cycle correctly right here. But I did get some of the vectors correct. I still attempted problems that were not in the back. And then this some proofs, which I felt were a little bit of a hand waving, but I tried them. And that's the whole point. Just try them. More hand waving attempts. This one was pretty easy. I mean, it's just straight multiplication. It's very clear. This took me like 3 minutes. Then in the answer to 4, I tried, but I think, let me see, is that the one that is back here, or is that something? I didn't print it because it was close. Yeah, I was pretty close to what they said, and this is the answer that they have. I felt that I was close in my proof. Of course, I want to go back to these t minus lambda I thingies, whatever they're called, in my final review. A couple of proofs that I felt I got, well, just that one, because that's part of section 7.3. Never mind, this is already in the book. So yeah, more attempts at proofs. Then reading section 7.3. Of course, always working out. I just like to work out whatever is done in the examples. All about the minimal polynomial. Then when it came to the problems of section 7.3, I got 2 wrong in the true and false. Then these were easy problems. Yeah, these were easy problems. Just minimal polynomials. That's all they were. And then problem 15 in section 7.3 is used a lot in section 7.4. So I made sure I attempted it, and I gave it my level best. I seem to be in the ballpark when I read this, but I did not use the full form of the polynomial with the remainder. I did not do that. But everything else, I think I was in the ballpark. And then I started reading section 7.4, and then of course the last video will be the reading of section 7.4 and a few problems, and then I'll be done with this book.